A particle moves on the hyperbola xy 40 equals 40 for t values greater than or equal to 0 seconds. At a certain instant, x equals 5, dx dt also equals 5. What is the value of dy dt? Well, what's nice about this problem is the equation given. You don't have to make it. So let's simply take the derivative of this in respect to time. Isn't it going to be product rule? Won't that be dx dt times y plus x times dy dt? And isn't 40 going to become 0? So the derivative of x, leave y, plus leave x, derivative of y, equals the derivative of 40 is 0. That's my derivative. Now looking at the data, can we start plugging in numbers? Yeah. dx dt, we know that right here is 5. So I'm going to put 5 here. Y, we don't know y, but we can find it. We'll come back to y, so I'm going to leave a blank for y. Do we know x? Yeah, isn't x right here? So can I put 5 right here? Aren't we finding dy dt? So dy dt is what I'm trying to find. So all I need is one more piece. I need one more piece and I can solve for dy dt. How do you find y? Well, could you simply plug your x into this equation to find y? So I'm going to take the equation. xy equals that. So it's 5 times y equals 40. I'll go back to the original. I solved that, so I divide by 5. So y is 8. So I'm going to put an 8 there. So I now plugged in 8 for y. I now can solve for dy dt. So let's do this. That will be 40 plus 5 dy dt equals 0. Minus the 40, minus the 40 over. So 5 dy dt is equal to negative 40. Divide by 5. So dy dt is equal to negative 8. I don't know the units. The reason I don't know the units is they didn't give me enough information. I know t is seconds, but I don't know what x and y units are. So I just call it negative 8. So the y values are decreasing by negative 8, but the x values are increasing by 5.